Welcome to the Jumble tool, the online application for structural analysis of data. In this video, we will show you how JSON files can be inspected and processed. Let's start with a simple example. JSON stands for JavaScript Object Notation. Our example file defines one top object. The object has 6 key value pairs: the S with value test, the N with value 123.456, the B with value true, the X with value null, the A which is a nested array, and finally the O which is a nested object. The nested array has another 6 values and the nested object has keys X, Y, T, N, and S. Once the file is uploaded, the data will appear as a graph. The root node of the graph is the upload node. It links the file node, which links the top JSON object. The key value pairs in the object are represented as 4 value nodes. The nested array is represented by this node, with its values represented as subnodes. Likewise, the nested object is represented by this node, with the key value pairs shown as its subnodes. Please note that the nodes have properties such as key, level, or value. The properties store data details. The key property stores the key of the item if it was part of an object. The index property stores the index in an array. The level property says how far is the node from the root node. The path property is a concatenation of all keys on the path from the root node. And finally, the type and value properties contain the value of the primitive data types such as strings, numbers, booleans, and nulls. In general, the nesting of the JSON is reflected by the structure of the graph. The graph nodes represent objects, arrays, and primitive data items. The properties of the nodes store additional data. Please note that some properties might be slightly redundant. For example, some scenarios might need the key property, in others the path might be more useful. While the data is on the right, the panel on the left contains the digest. We have made up this word to avoid heavily overused terms such as a model or a scheme. The digest shows a simplified view of the data, its structure, and statistics. All nodes with the same label are shown in the digest as one concept. For example, the 3 objects on the right are represented by this concept on the left. Likewise, all edges with the same label running from nodes with label A to nodes with label B are represented as one relationship. For example, the 8 edges from the JSON arrays to the JSON values are represented by this relationship. Some relationships might not seem intuitive at first glance. This relationship represents the edges between the nodes labeled object. It is a self loop, but the graph does not contain any self loops. This stems from the fact that multiple nodes are aggregated into one concept. In general, even when the data graph is acyclic, the digest might contain cycles. The digest shows representation of properties for both nodes and edges. It presents the name and the statistics for each property, how many times the property is used, and what the types of values are. So far, we have used a tiny JSON example. Let's see how the tool deals with something larger and more complex. This is a medium-sized JSON with a different structure. Once the file is uploaded, we can see that the graph is larger. It has over 1,600 nodes and edges. The digest, however, looks simpler than before. The structure is a subset of the previous digest. Some relationships are missing. No nested arrays, no arrays that contain just values. Besides this, the digest still shows that the graph consists of arrays, objects, and primitive values such as strings and numbers. This stems from the fact that the initial structure of the data reflects the packaging mechanism. So we need to process the graph to see how these items are organized. Please check the links below for that. Thank you for watching, and please let us know if you have any questions or comments.